Guys. In this video, I would like to explain the general procedure of hypothesis testing. We have done a video about hypothesis, the definition of hypothesis, and example from the real life. If you want to know about what is meant by a hypothesis in a statistic and what are the examples from the real life, you can see that video. The link is given in the description of this video. Just click on that link and you will see. You can watch that video and you will see what is meant by hypothesis in statistics and what are the examples of the real life. In this video, we will explain the 5, 6, or 7 steps which we can do in hypothesis testing. Some people say that's 5 steps, some people 6, and some people say 7 or maybe more. So you can see these are the steps in hypothesis testing. Start from formulating the hypothesis, stating the hypothesis, or we can say formulate your hypothesis. And then we say setting the significance level and then collecting the data and calculating the test statistic and calculating the p-value or the test statistic. We can use any of these two, but normally you can see p-value in the software and you can calculate test statistic. When you are doing manually, that's also okay because both approaches will give you the same result, and I will have separate video on these two approaches, how we can do hypothesis testing by using calculating the test statistic and how we can do hypothesis testing by using p-value and then make a decision and interpreting the results. That's the last step, 6 steps. So let's do go ahead and see how you can do these steps in hypothesis testing. Okay, so this means that you need to have formulate. The first step is to formulate your hypothesis, and that's mean null hypothesis and alternate hypothesis. So I'll explain here. Suppose formulation of hypothesis include like the first step is formulate your hypothesis. Your hypothesis. You can do this from your data. There should be some state in the data, and you should know how to do that from the data. So we do not normally it's not the null hypothesis that we will say suppose mu x is I will not say mu x. This is not sample test, so this should be mu. Okay, so this mu as equal to some particular value that should be mu, not a specific value. And of course, the alternate we denote by HA or H1, that is mu as not equal to mu naught. So now there are 3 possibilities. So one way is this, maybe here this, maybe like this, or maybe like H naught mu as less than equal to mu naught. Remember that the alternate hypothesis should be the opposite to this hypothesis. That sometimes we call rival hypothesis. That the opposite is mu greater than mu naught. Mu naught. And the third case possibility is H naught mu is greater than equal to naught. And the rival hypothesis or the alternate hypothesis in this case should be mu as less than mu naught. So this is the formulation of hypothesis. You can formulate hypothesis in any of these types from your data. We will do some examples, some problem. So we will see how you can formulate these hypotheses from your data. The second step is set a significance level. Set a significance level. That means set the value of alpha. Alpha, you can decide about the alpha, that's depend on the search objective, but this can be 0.05. That means 5% level of significance. And this may be 0.01. So that means 1% level of significance for this one. Or this may be 0.1. That means 10% level of significance. So you can choose any one of these three, but you can choose another one. That's depend on on the research objectives and yes, maybe it's given in the problem as well. So normally it is given in the problem, but if it is not given, you can choose any one of these three or maybe other. Third one is decide about test statistics. Let me just see that was the third step is okay, collecting the data. That's okay. You need to collect the data, but normally we have data given in the problem or in example. So we do that. We don't need that, but in the real life, when you are doing some thesis, some project, or you're doing some survey, you need to collect the data. So that's another very important step because without collecting the data, we cannot do hypothesis testing. And now then calculate test statistics. So let's see. Okay, now test statistic. Decide about test statistic. About the test statistic. That means we can use Z in different cases. We can use T in different cases. I will explain each of them separately, but this is important to see that which test statistic we can use. This again depends on the assumption. The data for T and Z, the data should be normally distributed. And for Z, the variances we need, the variances should be known, or if the variances are unknown and we want to use Z, the sample size should be large enough that mean the sample size should be greater than or equal to 30. And if the variance of the population data is unknown and sample size is small, in that case, you can use T statistic. So that means we can use Z, that is X bar minus mu divided by sigma divided by n square root. And this is normal distributed, standard normal distributed, by the way, with zero mean and unit variance under the null hypothesis. H naught. And the assumption for this test, okay, let's H naught. Assumption for this is data is normally distributed. Sample data, I mean, of course, the population distribution is also normal. The sample can be normal. So the population data is normally distributed. One, and this suppose one, and the population variance as known. This is another assumption. So in this case, we can use Z distribution. In the other case, if the population variance is not known and the sample size is large, in that case, we also use Z test, that's standard normal test. T test, that is X bar minus mu divided by S divided by N square root, and this is sample variance now. S is sample variance because sigma is unknown. So this is T distributed, student T distribution with n minus 1 degree of freedom and L. Okay, not we don't need to write this. That we can use to determine the theoretical region. So I will not talk about now about this. So this is T distributed under the null hypothesis H naught. And for this one, we have the same assumption. The first assumption is similar. This one. So this means this assumptions. And similarly, assumption are using T distribution. That is, a data is normally distributed normally distributed, and the population variance as unknown. Okay, so these are two assumptions for this and for Z. So now you have decided already about the test statistic. You can calculate test statistic. That's depend on the data. So any one of these can use. So that's depend on the data. Which test statistic you want to use, you calculate the test statistics. And what was the fourth step? Let's see, that is Okay, calculate the test statistic and then you can calculate the p-value. I will have separate video on this, so I will not talk about this now. I will just using the test statistic and the theoretical region. This approach is different approach. Okay, let's see. First step we are in. Okay, this is fourth. That can be not, should not be fourth. This should be fourth, by the way. And the third is collect the data. Collect data. And now fifth is calculate theoretical region or construct theoretical region. Fifth step. Construct critical region or rejection region, or rather it's better to use rejection region. Rejection region. So that's depend on now on rejection region entirely depend on the alternate hypothesis and the significance level. The direction of the rejection region depend on the alternate hypothesis. So I will explain this in a separate video developing theoretical region, rejection region. But now I can say for the null hypothesis, for this hypothesis, as we can say for this hypothesis, as the alternate hypothesis is in two-way because not equal to this is one way, greater this is one way. This for this one, I will explain for this one now, but there will be a separate video in which I will explain this rejection region for each case in detail. So in this case, there should be some point somewhere here that that rejection region should be greater than equal to z alpha by 2, and rejection region should be less than equal to minus z alpha by 2. We are using z test. So this suppose this point is z minus z alpha by 2, and this region is z alpha by 2. Just look at this. How we can write now, we have alpha is equal to 0.05. So this should be minus z 0.05, which is minus z 0.05. And similarly, this should be 0.05. Now just look at the table. So this is the rejection region, and this is the rejection region. Rejection region and rejection region, and this is acceptance region. So when you see this point from the table, synonym table, and this point, you will see, and you calculate the test statistic, by the way, in the previous step, as explained. Calculate this test statistic in this step, and then see if the test statistic value is less than equal to this value. You will see this from table. Let's see this from the table first. It's important. Let's see how we can. Okay, let's see this from the table. Standard number table you can use for this. I hope we have, yes, we have this table. So just look at this, the value, that's mean z. And by the way, this variable is z on the x-axis. Okay, so this is z 0.025. Just look at this probability at this point to determine the value of z. And remember, we already calculated the value of z in the fourth step. So we need to compare the value of z. And in the p-value, we need to calculate the probabilities. I will talk about this some next lectures. Okay, just look at 0.025. 0.02. Oh, this is exactly the value, 0.025. And look at this, that is minus 1.96. Just look at this. If you want to know, if you don't know how to see the table, I have a video on this, and this will go to the link Given link is given in the description of this video. Just go and click, and you will see how to use the table to see the value of z from the given probability. So this is the probability given 0.025, and you can see the value of z, that is 1.9 in combination with this, so 1.96. This is minus 1.96. Remember that this probability is similar to this probability because this distribution is symmetric. So probability less than this point is equal to probability greater than this point. You can calculate this probability, by the way. The total probability is equal to 1. So you can calculate 1 minus the probability until this point. Just subtract this probability from 1, you will get this probability. But that is difficult. You don't need to do. Due to symmetry, we can see only this point in table, and we can have this value as well. So from table, this value as minus 1.96, by the way. And this value is, of course, 1.96, positive and negative. Now you need to calculate that statistic and see if the value lies in this region, you accept the hypothesis, the null hypothesis. And if it lies in this region or in this region, you need to reject the null hypothesis and accept the alternate hypothesis. So the sixth step is now conclusion and interpretation. Sixth step is conclusion and interpretation. So in this specific example in which you have these points, the rejection region is here and here. So we say accept H naught if the test statistic value calculated as less than equal to minus 1.96, or test statistic value is greater than equal to 1.96. This means if the test statistic calculated value is less than equal to this or greater than equal to this, reject, accept, no, this is reject, sorry. This should be reject. Okay, so not accept. Reject H naught. Reject H naught, the null hypothesis f TS is less than equal to minus this value, because if the value is in this region, reject null hypothesis, and if the T value is greater than equal to this one, reject the null hypothesis and accept the alternate hypothesis. And then you can write the interpretation. So this is the general this was the general procedure about hypothesis testing, that how we can test hypothesis generally. In the next video, we will do something about calculating theoretical region, and also we will have some calculation video with the calculating p-value, and because there are two approaches. One I have discussed about this, comparing the test statistic with the values you calculate from the significance level, like this. Like you calculated the test statistic, and then you see the values of the z variable and this x-axis from the given probability of value of alpha. So this value is for z minus 1.96 and 1.96. And then you compare the calculated value with these 2 points. And the next video will also have some comparison with by using the p-value. So both approaches give you the same result. You don't need to worry, but and most of the software you see the p-value and you are doing. So thank you very much, and see you in the next video. Ciao.